Okay, so let's talk about gas exchange. All right, so in gas exchange, the first thing we have to have is ventilation, right? So you have to breathe air in, so breathe oxygen in and to be exchanged, and then exhale and breathe air out and CO2 with it. So first, there's two phases of gas exchange. There's external respiration and internal respiration. So we have ventilation, which is getting the air in, getting the air out. External respiration. Skip myself there. Then we have transport. Then internal respiration. Cellular respiration. And transport again. Okay, so external respiration is gas exchange from alveoli to blood. Internal respiration is blood to tissue and vice versa. Okay, and then transport, once we get the oxygen into the blood, we got to take it to tissues, so that's transport. We got to take the and then we've got to, exchange with the tissue with internal respiration, and then we have to transport the CO2 back to the lungs to get rid of it. And then the cellular respiration I just throw in there because that's the use of oxygen and the creation of the carbon dioxide. So I'm going to draw you a picture that's weird. So I'm going to draw you a big fat alveoli, or weirdly shaped alveoli. So here's this tube going in. I'm going to draw my alveoli really weird. Okay, looks like a foot. All right, so alveoli there, and then I'm going to draw a blood supply. So here's vessels here. Vessel here. Here's the end of my vessel. I hope you know what I'm going for here. Sort of. And then down here we have tissues. So here's my tissue cells. Okay, so we know the blood runs in one direction. Okay, so the blood is running this way. Okay, we're kind of bypassing the heart, but blood is just running in one direction anyway. I'm sure you realize that. Okay. All right. So in the atmosphere, the partial pressure of, I'm going to do these in particular colors here. So PO2, that's the partial pressure of oxygen in the atmosphere, is about 160 millimeters of mercury. Okay. All right. The partial pressure of CO2 is about 0.25 millimeters of mercury. Okay. Now I'm going to divide my lung. in half. Okay? And this half over here is going to be air in, the air that's coming in. This half over here is going to represent the air going out. Okay? All right, so when I breathe air in, air is coming in. The PO2, partial pressure of oxygen in the lung in a breath in, is 100 millimeters per mercury. The PCO2, trying to keep my colors, but the PCO2 is 40 millimeters per mercury. Okay, that's on a breath in, all right? The blood that's coming to the alveoli, those capillaries, is deoxygenated. Okay, the whole purpose is to do gas exchange here. So, okay, so in the blood coming into the lung, the PO2 is 40 millimeters per mercury. And the PCO2 is 45 or 46 millimeters per mercury. We'll say 46, doesn't really matter. So 46 millimeters per mercury. So as the blood is coming in and you've taken an air in, look at the pressures. The partial pressure of the air in the lung is 100. The partial pressure of the air in the capillary is 40. So what's going to happen to the oxygen? Oxygen is going to diffuse in. Okay, when it diffuses in, that blood becomes oxygenated. So at that point, the blood's PO2 rises to 100 millimeters per mercury. The CO2 in the deoxygenated blood is higher than the CO2 in the lung. So the CO2 is going to go into the lung. So now the PCO2 in the lung raises to 46 millimeters per mercury. And now that the oxygen has left, the PO2 is going to be reduced to 40 millimeters per mercury. So that air is going out. Okay, so we can breathe out some of that CO2. Okay, the PCO2 in the oxygenated blood is reduced to 40 millimeters per mercury. Okay, so that is external respiration. So that is just what we just did. Okay, now the blood is transported to the tissues. So now we're at the capillary bed of the tissue. When the blood enters the capillary bed, it's oxygenated. So the PO2 at the beginning of the capillary bed is going to be 100 millimeters of mercury. The PCO2 coming in is going to be 40 millimeters of mercury. Okay. In the tissue, the tissues are using the oxygen. So in the tissues, they're going through cellular respiration, so they're making CO2. So their PCO2 is 46 millimeters of mercury. The O2 is 40 because they used it to make energy. So as the blood comes through, the oxygen comes into the tissue, okay, makes the tissue now 100 millimeters of mercury, and the CO2, the PCO2, the carbon dioxide goes into the blood, and now the PCO2 is 40 millimeters per mercury. So it goes to there. This one goes to there. Okay, so now at the end of the capillary bed, the PO2 is 40 and the PCO2 is 46. We get transport back to the lungs, and again, PO2 is 40, PCO2 is 46, and then we exchange again. So over here then was internal respiration. Okay, so it's basically only two numbers you need to know, but you don't really need to know them. Just know that obviously when you breathe in, your amount of oxygen in your lung is going to be high. The blood coming in from the tissues, really from the heart, to the lung is going to be low in oxygen. Then we have exchange. It's going to be high in PCO2 and carbon dioxide, so that's going to exchange there. Okay, and then of course the blood has to be transported to the tissues, where in those capillary beds, gas exchange occurs the same way from high to low. Okay, so that is basically gas exchange. All right, what affects gas exchange? Well, there are certain factors that do affect the ability for the gas to exchange. And number one is partial pressure differences. Okay, there has to be this partial pressure difference, this gradient, in order for that to occur. Okay, so if you're not breathing well, or you can't breathe in, or you're in an area, maybe high altitude, where you're not getting that much oxygen, there's not going to be a lot of exchange because the gradient isn't going to be there. So the pressure differences. The distance between the alveoli and the capillary. So there's this interstitial space here. If there's edema there and that space is getting bigger, it's going to be harder for those gases to come across, especially oxygen. I've mentioned this before. Oxygen is not very soluble in water. CO2 is. So CO2 can kind of come across a long way, but the PO2 is going to have trouble. The oxygen is going to have trouble diffusing across a long way because it isn't very soluble. The surface area of the alveoli, okay? You know, people that have emphysema, that breaks down, remember the elastin's breaking down and the walls of the alveoli are breaking down. So they're losing surface area. So there's not as much alveoli near the pulmonary veins, pulmonary capillaries. So less oxygen will be exchanged that way. So run through this. This is a little different than your notes as far as the PowerPoint. The PowerPoint has it kind of separated out into, external respiration and then another plate for internal respiration, and I just put them together for you. So compare those, and you should be able to understand that. If not, just let me know.